The next phase of this assignment is to go to page 188 of your textbook. So go to page 188 of your textbook, and you're going to figure out which equation or function matches each of these sequence. So sequence A is these numbers. So you'll want to refer back to your slideshow, slides 12, 13, 14, and 15 from the part of this assignment that came before. And sequence A is the function that's points were 1, 3, 2, 6, 3, 12, 4, 24, and 5, 48. So term 1, term 2, term 3, term 4, and term 5. So your terms, they look like this on your slideshow, right? 1, 3, this is 1 point. Another point is 2, 6. 3, 12. 4, 24. 5, 48. So you'll have 5 points, and the last point will be 5, 48. That's sequence A. In sequence B, you still have terms 1, 2, 3, 4, and 5, but this is an arithmetic sequence. So this one starts off with point 1, 3. It also has point 2, 6. It has the point 3, 9, the point 4, 12, and then it ends with the point 5, 15. So you're going to graph 5 points for sequence A and 5 points for sequence B. And your points are listed here. So now, let me get rid of these. The other thing to remember is what you know about arithmetic sequences and geometric sequences, because you're going to be asked on this page to explain some of the characteristics of the graphs. So some of the things that are true about geometric sequences and arithmetic sequences, you're going to want to remember. So geometric sequences are the ones that multiply to get from one term to the next. I'm going to draw an asterisk, meaning multiply. And arithmetic sequences are the ones that add to get from one term to the next. For example, in this sequence, sequence A, we're multiplying by 2 each time. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. In this sequence, the arithmetic sequence, we're adding 3 each time. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. So we have a geometric sequence and we have an arithmetic sequence. So when you graph these, look at some of the characteristics of these graphs so you have something to write about when you're comparing and contrasting. So let's graph some points. First of all, look at the axes. The x-axis, each of these lines is 1. So 1, 2, 3, 4, 5, 6, and so on. On the y-axis, each line is 2. So 2, 4, 6, 8, 10. And I know that this assignment tells you to use triangles for A and squares for B, But since you're writing this in your book, if you want to use, instead of using shapes, if you want to use different colors, feel free. So I think what I'm going to do for my purposes for this, since it's hard to draw the little triangles and the little squares using the technology that I'm using, I'm going to use I'm going to use a little peach colored rectangle for sequence A, and then I'll use a little green tinted rectangle for sequence B. All right, and I'll keep them as close to the points as possible. So let's see. So first things first, let's graph these terms for, oops, I used the wrong color. My bad. Let's graph these terms for sequence A. So sequence A, the first point is 1, 3. So I'm going to go to 1, and then I'm going to go up to 3. So this is 2, and then 3 is right here at the tip of the pencil. So about right here, the middle of this rectangle is at about 1, 3. And I think I'll put a little dot in, a point in there so it's more clear. So there's the point. That's point 1, 3. And then I'm going to go and plot point 2, 6. So 2, 6, here's 2, and then I'm going to go up to 2, 4, 6, and there's that point, and I'm going to put a little dot to mark the spot. So I'm at term 2, and then I'm going to go up 2, 4, 6, and here's my point. Okay. Now 3, 12. So I'm going to go, I'm at 3, and I'm going to go 2, 4, 6, 8, 10, 12, and mark my spot, and then put a little point. 2, 4, 6, 8, 10, 12. And the graphing, you can't see the pattern too much yet, so let's keep going. The next point is 4, 24, so let's see, I'm at 4, here's 20, 22, 24, and then I'm going to put a little point there. That's a little bit off, it's actually a little bit more over here. And then my next point is 5, 48. So 5, and then up to 48. Here's 40, 42, 44, 46, 48. And then I'll put my point. So you can see that this is not a straight line. If you drew a curve through this, it would start off kind of slowly and then it would grow up really fast. So remember that when you graphed this on Desmos, it started off real slowly and then it went zip up really fast. It made a curve. Okay, that's the graph for G of n. For function G, it's exponential. Now let's graph function A. I'm going to do that with my green. So function A starts off with 1, 3. So 1, 3, that's the same point. So my pink and my green overlapped there. Now 2, 6, that also overlaps, it's right here. 3, 9. So I'm going to go up to 3, I'm going to go over to 3 and then up to 9, 2, 4, 6, 8, 9. And then I want a little point there. So 9 is halfway in between 8 and 10. Now I'm going to 4, 12. Here's 10, a little bit higher to 12. There's that point. And then 5, 15. So here's 5, and then up to 15. Here's 20, 18, 16. So 15 is right there. It gets a little messy. 5, 15. 5, 2, 4, 6, 8, 10, 12, 14, 15. Yeah, right here. Now, if you look at the ones we just graphed, they're making a line, right? The green is making a straight line. So a of n, our arithmetic function, where we're adding 3 each time, that is making a straight line. All right, so make sure you get those graphs in your book. You'll have one that turns up looking like a curve and one that looks like a line, an exponential graph and a linear graph. And then go ahead and find 3 things that they have in common. So they have some points in common. They both have these points. They both are increasing. They both go on forever in both directions. They have a lot of things in common. So list some things they have in common, and that will be, you'll be done with page 188.